何してるの？
今度のレポートで夢のような未来の技術について調べてるんだけど、どんな内容がいいんだろう？
未来はどんなことができるようになってるのかな。あ、そうだ。どんな未来を目指している人たちがいるのか、これに聞いてみようよ。ねえ、教えて。
Yes, certainly. Research on technologies shaping the future is underway at QST. QST, the National Institutes for Quantum Science and Technology, was established in 2016 as an organization dedicated to studying quantum science. At QST, scientists use unique phenomena occurring in the quantum world to advance research that challenges conventional wisdom.
面白そう。調べてみようよ。まずは、量子って何だろう？
Quantum refers to very small units of energy or matter. Quantum properties can appear in the ultra-microscopic world of about 1 billionth of a meter. One example is the mysterious phenomenon known as quantum teleportation. The potential applications are limitless, including information processing and communications, the semiconductor industry, life sciences, the environment, energy, and space. QST conducts a wide range of research and development, from energy innovation to medical and healthcare advancements utilizing quantum properties, aiming to change the world dramatically.
量子を研究することで、未来の暮らしを変える技術が見つかるかもしれない。
量子を研究している QST では、どのようなことが研究されてるんだろう？教えて。
Quantum technology utilizes the properties of quantum particles that function in the microscopic world to enable information processing and communication, etc. QST is driving innovation through research and development aimed at realizing a super smart society using such quantum technology. Quantum technology, such as quantum computing, quantum communication, and quantum sensing, uses the properties of quantum particles functioning in the ultra-microscopic world in areas such as information processing, communication, and measurement. QST researches and develops quantum materials which are essential for these efforts.
I developed new equipment and data analysis methods to study quantum materials, which have unique properties. By examining how electrons move inside these materials, I aim to uncover the properties of the quantum materials. My equipment requires bright light, like synchro radiation, to excite electrons in the material and make them escape. By analyzing their movements, we learn how electrons behave inside the materials. This also requires an ultra-high vacuum similar to outer space. My research contributes to Spintronics, a technology that uses the magnetic property of electrons to make faster and more energy-efficient smartphones or computers while saving battery power. I want to develop new equipment that challenges existing limits and uncovers new properties of materials. My goal is to turn impossible ideas into discoveries that benefit society.
Furthermore, it is also conducting research and development on quantum devices, which are the basic components of quantum technology.
My study is to develop new types of quantum devices that are the building blocks of quantum technologies. Quantum technologies will be widely used in our life in the future. My research results will be used in society.
へえ、QST では超スマート社会に向けた研究をしてるんだね。
他にはどんな研究をしてるんだろう？
Quantum life science is a new field of research aiming to clarify what is life using quantum insights and techniques. By leveraging new methods employing quantum technology, researchers are not only discovering previously unknown microscopic mechanisms of life, but also working to drive innovation in medicine and other fields.
1個の5ナノメートルのセンサーを使えば、例えば、その、微小環境の温度を測りながら pH を測る、あるいはラジカル濃度を測る、電波磁場を測る、そういったものが同時に行えるというのがナノ量子センサーの特徴になります。例えばワンクリックで、何十万と存在している細胞をこう一個一個解析できるような、そういったシステムであったり、あるいはもう顕微鏡の形すらしていない箱型の筐体の中に、例えばウェルプレートを入れたらその細胞を全部解析してくれる、そういった、量子センシング装置を開発することで、より幅広い、今まで、はあまり量子技術に触れてこなかったような、生物学の研究者、あるいは製薬会社の方々であったり、お医者さんであったり、そういった方々に利用いただけるような、そういったシステムの開発の方向に進んでいこうとしています。
そんな夢みたいな未来に向けて研究が進められているんだね。
うん。生命の謎を解き明かす研究だなんて、新たな可能性が広がってるね。
Toward a healthy and long-lived society with 0 deaths from cancer and no dementia. Since developing the world's first heavy ion cancer treatment system, REMAT QST has significantly contributed to improving patients' quality of life and advancing cancer treatment. By leveraging their strengths, including QST hospital and radiation effects research, they also promote integrated research and development from basic to clinical research and actual medical practice.
I specialize in carbon radiotherapy for bone and soft tissue sarcomas. Sarcomas are a type of cancer that is generally resistant to radiation treatment and were previously considered untreatable with radiotherapy using X-ray beams. The use of heavy ion beams improves radiation quality. The impact of radiation quality has attracted attention. REMAT is the only equipment in Japan capable of producing large heavy ion beams for medical use. Our hospital is the sole facility where large heavy ion beams are applied in clinical practice.
To further popularize heavy ion cancer treatment globally, QST is advancing projects like the Quantum Scalpel Project, which aims to develop compact heavy ion treatment devices.
The Quantum Scalpel Project first aims to democratize heavy ion therapy by downsizing conventional heavy ion therapy equipment. The second aim of the Quantum Scalpel Project is to expand conventional heavy ion therapy using a single particle type like carbon ions to multi-ion irradiation using mixture of helium, carbon, oxygen, and neon for more effective treatment. By making heavy ion therapy more effective, cancers that were previously challenging to control can be cured. Also, the quality of life of the patient will be improved by shortening the duration of treatment.
QST is also engaged in research and development of technologies to quickly and accurately diagnose mental and neurological disorders such as dementia, as well as drugs to prevent their onset and progression.
At Advanced Neuroimaging Center, where I work, we are engaged in research on the diagnosis and treatment of mental and neurological disorders such as dementia and depression. For instance, I recently discovered a mechanism by which applying ultrasound to the brain, it enhances neuronal activity. We are hoping this discovery can be used to treat dementia and depression in the future.
がんや認知症って治りにくい病気だと思ってたんだけど、どんどん治療方法が進んでるんだね。これも未来を変える技術だね。
すごい。もっともっと調べてみようよ。
うん、調べてみよう。
QST is also working on research and development to protect people from radiation exposure in case of an unforeseen incident. In the event of radiation exposure or contamination accidents caused by radioactive substances, QST has established the Radiation Emergency Medical Assistance Team, REMAT, to support initial medical care on site. REMAT comprises experts in the fields of radiation medicine, radiation protection, and radiation dose assessment and conducts research aimed at the diagnosis and treatment of radiation-exposed patients.
QST では未来の生活や医療だけじゃなく、いざという時のための研究もしてるんだね。
でも未来といえば大きなエネルギーや環境の問題も心配だね。
A massive international project to create a sun on the Earth. The sun is thought to have been born 4.6 billion years ago, and the source of its brilliance is nuclear fusion. QST is actively engaged in research and development aimed at recreating that fusion process on Earth and is also advancing research on fusion energy, the energy source of the future.
My research aims to realize the fusion energy, which has the potential to solve the urgent energy problems and serious global environmental problems, such as global warming. The JT-60SA device integrated various cutting-edge technologies, including the ultra-high vacuum, the superconducting coils at the extremely low temperatures, high voltage, and high current. My work is to integrate these technologies and ensure that the JT-60SA functions properly as a plasma experimental device. Furthermore, the JT-60SA project, an international collaboration between Japan and Europe, has strong connection to the ITER project. This gives me the opportunity to engage in research and development using internationally significant devices, which is another key attraction. I aim to fulfill the dream I had in junior high school to make a fusion energy reactor a reality with my own hands.
To realize fusion energy, QST is promoting the development of a device called a blanket that stably extracts energy as heat and conducting research and development aimed at the early realization of practical fusion reactors.
I'm designing and developing a new energy source called a fusion demo reactor. When it is, we will be able to deliver large amounts of electricity and other forms of energy to your homes without emitting carbon dioxide. My plant system design study is to determine which components and which parameters are key to improving the performance of the plant by looking at the overall balance and pointing in the direction of making of the plant as a whole or more attractive. It is a conductor in research and development. I hope that in the future, my children and their grandchildren will be able to use fusion energy and live in affluent society in harmony with nature.
フュージョンエネルギーで発電ができれば地球環境に優しく安全な世界が実現するね。
今までのいろんな話、みんな量子がキーワードだったよね。量子ビームっていうのもあるらしいんだけど、それも QST で研究されてるのかな？
Of course, QST is researching that as well. The last thing we will introduce is quantum beam research. Quantum beams are generated using large accelerators and laser devices, and they can be used to observe and manipulate the state of matter at the atomic and molecular levels. Quantum beams include ions, electrons, neutrons, and X-rays, and support a wide range of science and technology fields, from basic research to industrial applications.
I use the world top-level high-intensity laser system called JCurrent at KPSI. Once the laser energy is compressed into a very small temporal and spatial region, the laser pulse can make extraordinary high electric field within that area. If any material is exposed to the field, it is evaporated, heated up, and being a plasma instantaneously. If we can manipulate the plasma as we want, we can make by far the stronger acceleration field than the one achieved in currently existing conventional accelerator, and we can establish an advanced accelerator system. Because our J-current laser facility is our own developed system, we can optimize as we want for specific experiments, which is totally different from the situation when we use joint usage laser systems.
There is also the NanoTerasu synchrotron light source, which can utilize soft X-ray nanobeams that are the brightest in Japan. It consists of a 110-meter-long linear accelerator and a storage ring that confines accelerated electrons to a circular orbit 349 meters in circumference, supplying synchrotron radiation to the experiment hall. Using a giant microscope, the facility generates synchrotron radiation that is about 1 billion times brighter than sunlight, allowing researchers to visualize the structure and function of materials at the ultra-microscopic level.
At the NanoTerasu synchrotron radiation facilities, we are constructing beamlines to bring soft X-ray synchrotron radiation into the experimental hall, adjust the light for various purposes, and deliver it to the experimental equipment for users. At QST, we are constructing 3 beamlines that use high brilliance soft X-rays of NanoTerasu for advanced research in soft X-ray spectroscopy. By making full use of NanoTerasu's powerful light source, the beamline can achieve top-level energy resolution and microfocusing performance. And we will keep the beamline and equipment stable and well-maintained. Additionally, we will work on introducing advanced technology, improving the capabilities of the beamlines, and also constructing new beamlines.
QST has large-scale facilities that promote the development and advancement of the generation, control, and technical application of quantum beams, including ion beams, electron beams, lasers, and hard, soft X-ray synchrotron radiation. Each facility offers unique quantum beams and environments dedicated to their use. Together with researchers and engineers from Japan and overseas, QST works daily to develop new industries and strongly support people's lives, moving forward to connect to an even brighter and richer future.
すごすぎる。量子ビームで今まで分からなかったものが分かるようになる。
もっと小さな世界を、もっと速い動きを、もっといろいろな物質をもっと精密に調べたいっていう研究者の思いが高度な量子ビーム技術を次々と生み出してるんだね。
こんなに高性能な量子ビーム施設がいろいろ揃ってるところは世界でも珍しいよね。それを活用して新しい発見や発明が生み出されてるんだね。
そんな私たちの想像を超える研究をしている QST が考える未来ってどんなんだろう？
Everything in this world is made of quantum. Quantum is a tiny, tiny thing, and it shows a strange behavior. When we understand its nature and handle it freely, a whole new world opens up. For example, we can see what we could not see before, and we can do what we could not do before. We can even understand what we have never imagined. For example, our life. I believe we can understand the mystery of life through quantum. And then we can develop new technologies to make us life much healthier. QST will continue various research and development with quantum as the keyword, and will contribute to the realization of a sustainable society where we all live happy and healthy life. I appreciate your continued support for QST.
そうか、私たちが夢物語だと思って語っていた未来は QST が叶えてくれるんだ。
夢みたいな未来は夢じゃない。QST が研究してるから未来はすぐそこにあるんだ。
Knowing about QST opens the door to a future with limitless possibilities.